Hey everyone! Today we're diving into a topic that's pretty much a guaranteed gold mine for marks in your board exams. All the factors that affect how plants absorb water. Let's get right into it and make sure you can absolutely nail any question that comes your way.
So why are we focusing on this? Well, check this out. This one concept is worth 2 to 3 marks year after year. Now, in a big exam, those are points that can make a huge difference, and we are definitely not going to leave them on the table.
And look, this isn't just a hunch, it's practically a known fact. These marks are consistent, they're predictable, and honestly, after this quick explainer, they're going to be yours. We're going to make this whole thing super simple to understand and even easier to remember.
Okay, so here's our game plan. We'll kick off with why this is so important, then we'll break down the core science. After that, we're going to walk through an actual exam problem, look at the common mistakes people make, and I'll even show you how to present your answer for full marks. Then we'll wrap it all up with a quick recap. Let's do it.
All right, first up, why this topic matters. Like we said, getting this right gives you a serious edge. It's one of those areas where a lot of students make tiny but really costly mistakes. If you understand it deeply, you can easily stand out and give your final score a nice little boost. Okay, moving on to the core concepts. Let's get to the good stuff, the science. There are really 3 main environmental factors that decide how well a plant can soak up water. And the whole thing is driven by this key biological idea called osmosis. We're going to break down each part with some simple, everyday examples you won't forget. First on the list is available soil water. Now, this sounds super obvious, right? But the magic word here is available. It's not just about how much water is in the ground, but how much the plant's roots can actually get to. There's a sweet spot. Too little, the plant wilts. Too much, and you've got a whole other problem.
The sponge analogy is just perfect for this. If the soil is bone dry, like a crusty old sponge, there's obviously nothing for the plant to drink. But if it's completely soaked and waterlogged, it creates a brand new issue, which we'll get to in just a sec. Plants are happiest in that just right Goldilocks zone of moisture.
But hey, having water around is only one piece of the puzzle. The environment that water is in matters a ton. Which brings us to our next big question. How exactly does temperature fit into all of this? The main thing you've got to remember is that roots are alive. They're made of living cells that are constantly working, using energy to absorb water. And just like any other biological process, all that activity is hugely influenced by the soil's temperature. And this is a brilliant way to think about it. If it's freezing cold, the root cell's metabolism just slows to a crawl. If it gets way too hot, their important enzymes can get damaged. Just like us, roots have a comfort zone, usually somewhere between 20 and 30 degrees Celsius, where they can do their best work. And now, for our third factor, and honestly, this is the one that so many people forget, soil air. This is absolutely critical. See, absorbing water isn't passive, it takes energy. And to make that energy, the root cells have to perform respiration. And what does respiration need? You guessed it, oxygen. This brings us right back to that waterlogged soil problem. When every nook and cranny in the soil is filled with water, there are no air pockets left. No air means no oxygen. So, a plant in waterlogged soil is literally drowning. Its roots can't breathe to make the energy they need to drink. It's a crazy paradox. The plant is surrounded by water, but it can't absorb any of it.
Okay, so we've got the theory down. Now let's put it all into practice and solve an exam problem. This is where we turn all that knowledge into actual marks.
Whoa, hold on. Before we solve anything, you need this. As I said, the whole process is driven by osmosis. So go ahead, take a screenshot of this definition. You need to know this by heart. Seriously, it's the key that unlocks pretty much every question on this topic. Here is your 4-step playbook for the perfect answer. Step 1, understand the question. Figure out what conditions they're giving you. Step 2, apply the concept. Connect it to one of our 3 factors. Step 3, explain the why. Use those key terms like osmosis and respiration. And finally, step 4, write your final answer, clearly stating how absorption is affected. Easy. Now, knowing how to answer is great, but knowing what not to do, that's what separates a good score from a great one. So welcome to section 4. Let's talk about the common pitfalls so you can just step right around them. Okay, listen up. First, please don't mix up osmosis and diffusion. Second, stay focused on the roots. Photosynthesis happens in the leaves. It's irrelevant here.
Third, always mention root respiration. It's the engine of this whole process. And last, be specific. Don't just say it gets bad, say the rate of absorption decreases. Use scientific language.
You could have the most amazing answer in your head, but if it's presented poorly, you're just not going to get full marks. So for this section, let's talk about nailing your presentation, making your answer look as smart as it actually is.
Here's your checklist for a perfect-looking answer. Use headings. Underline your keywords so they pop. If it helps, draw a quick, simple diagram. And please use bullet points or short paragraphs. You want to make it as easy as possible for the examiner to see how smart you are and give you those marks.
And really, that's the formula. It's that simple. A clean, well-organized answer just screams confidence and clarity. It makes it a no-brainer for the examiner to give you every single mark you deserve.
Wow. Okay, we have covered a lot in a very short time. For our final section, let's lock in all this knowledge with a super fast recap and a quick look at what comes next.
All right, here's your 30-second summary. Ready? There are 3 key factors: soil water, soil temperature, and soil air. The whole process is osmosis, and it needs energy from respiration. And the biggest mistake to avoid? Forgetting that roots need oxygen to breathe. Got it? Awesome.
So what's the next step for you? Well, now that you totally mastered how water gets into the plant, the next logical thing to learn is how it travels up the plant. That process is called transpiration pull, and it's the perfect topic to tackle next.
And that is a wrap. You've just mastered a topic that is basically guaranteed to get you marks. You are officially one step closer to acing your exams. Keep this focus, keep practicing, and just stay consistent. You've totally got this.